Hello, in this video let's discuss fourth question of today's contest. You are given four integers xx, sx, sy, tx and ty representing two points at 2D coordinate at infinitely large 2D grid. You start at sx and xy. At any point you can move to x plus maximum of xy and y or x comma y plus maximum of x and y. Return the minimum number of moves to reach tx comma ty. If it is impossible to reach, then return -1. And the constraints are both are up to 1 in 9 and similarly tx and ty are also up to 1 in 9. So the first thing is we have to find the least time to reach the tx comma ty. So the first thing is simply bfs because it will give the least time or least number of moves we can take to reach the final point. So but simply normal bfs will use tl because it is a 2D large 2D grid with x and y limiting to 1 in 9. So it will take off m plus n, which is approximately very high and which is very bad. So the simple BFS can be, we can start from x and y and then we can find whether we will simply insert this and this into BFS and then we can do this until reaching the higher point. But this will give tally. So what next? So there are two main things for this. Let's discuss one by one. So this is the first one. So we cannot simply use a Western matrix to find whether xy coordinate is listed before because both are 1 in 9. We cannot store a matrix of 1 in n, 1 in n. We cannot store at least 1 in n, so we cannot store 2D of 1 in n. So simply, how can we find whether it is already visited or not? So simply we have to find a way to represent a coordinate xy in a single value. So that then we can say that we can simply find whether it is already visited or not by single value. Because if we find a unique value, then we can find whether it is already visited or not. Because we can store in a set or anything, and then we can find whether this is already in the set or not. So we want a unique value representing distinct coordinates. How can we do that? Can x plus y be answer? Obviously be no, because for 1 0 and 0 1 the value is same. So we want a unique hash function where that describes the unique value for every coordinate x and y. How can we find that? So x and y is less than or equal to 2 power 31 because they are less than 1 in n. So for x and y, what can be a unique value that is representing this? For example, there are strings, right? Let's assume the first string is high and the next string is by. Then what can be a simple string that can be merge of this? It can be simply high by, right? Because for example, we are adding a comma and then we are inserting. So high comma by is obviously one of the choice. And there cannot be any other strings combination that it can be possible. For example, let's assume HIB and YE. So if these both are the strings, what are the new string possible? Then we will add the comma here. So it will be HIB comma YE. So these both are not equal. So if that would be a string, then we can simply add the first string, then comma and the second string. But these are integers. So what if we try to append these in the original number? So this is x and y, right? So what if we shift the x by 32 times and then add y? It is simply like x and y, right? So x and x less than 32 indicates that we are multiplying x by 2 power 32. So that the whole x will be shifted by 32 and all the other digits will be 0. 0 to 31 bits. And now we are adding y here. So in this way, this is exactly this way, but for numbers. So in this way, we can find a unique hash function for x and y where we can find whether it is visited or not by single value, no need of any matrix. So hope you understand why this is less than and why this is plus. Or we can use bitwise or we can use anything by checking whether it can be a unique value or not. So the first condition is we achieved whether how to find whether a coordinate is visited or not. Let's come to second one. So BFS from starting point to ending point will give tally. So how can we change it? So instead of forward iteration, let's come from backward because we got that going forward is giving tally because we have to achieve both possibilities. But let's assume we are coming from back and then find whether we can reduce any optimization or not. So let's assume we are initially at 0, 0 and let's assume that we are at x and y. So we are at x and y. Then what are the before x and y coordinates where we can reach the present x and y? So in the question we have given that they given that from xy we can reach to x plus maximum or y plus maximum. So obviously if we are reaching x and y from before coordinate, it should be some x comma b or it should be from a comma y. It cannot be some random point where we can move diagonally because we can move only right or only left. So when we are coming back, we will check whether we have come from down or we have come from left. So at xy, we can have come from xb or ay. So how can we check from these both? So let's take many examples and understand which are the possible cases. So coming to first one, initially we are at 0, 0. And now let's assume we are at 10, 4. So we are at 10, 4. So what is the possible x comma b where we came from x comma b? So let's assume, because they have given that from xy, we can reach x plus y. So for now, let's assume we are at x greater than equal to y. So we are at point x comma y, where x greater than equal to y. Now let's try to simulate the before possible coordinates from where we have reached x comma y. So the first thing is simply x minus y comma y, because we already discussed that x is greater than equal to y. So if x is greater than equal to y, then the before coordinate can be x minus y, so that the maximum will be y, and then we will add this, then we can reach x. So if we are reaching x minus y, the first thing where we could have reached this is simply x minus y comma y. So for 10 comma 4, what is the before coordinate? It will be 6 comma 4, because 10 minus 4 is 6. So 6 comma 4. So from 6 comma 4, we might have reached 10 comma 4. Is that correct? Obviously no, because from 6 comma 4, if we try to go in the x direction, it will be 6 plus maximum of 6 comma 4, which is 6. So if we are trying to reach from 6 comma 4, we will reach 12 comma 4, but not 10 comma 4. So this is not the right condition. So this is not the correct one. So now let's come to 10 comma 6. For 10 comma 6, can we come from 4 comma 6, where 4 is 10 minus 6? Yes, we could have come from 4 comma 6, because for this 4 plus maximum will be 10. 4 plus maximum 4 comma 6 is 6. So 4 plus 6 is 10. So from 4 comma 6, we might have reached 10 comma 6, but from 6 comma 4, we could not have reached 10 comma 4. So what is the case that is distinguishing this both? It is simply x and 2y. So for 10 comma 4, x is not less than equal to 2 into y, because 10 is not less than equal to 2 into 4, which is 8. But for 10 comma 6, 10 is less than equal to 12. So if this is the case, then we can have reached from x comma y, because x is less than equal to 2 into y. So x minus y is also less than equal to y. So if x comma y is less than equal to y, this is the case, then x minus 1 gap can be a possible before coordinate from where we have reached this. So that x comma x minus y plus maximum of these both, which is y. So x comma y plus y, then it will be x. So if x is less than or equal to y, only then the new only then the old point can be x minus y comma y. So this is the first condition. And now, is that the only condition so that we can reach from the other point? No, because let's assume the point we are at 4 comma 2. And now coming to before one, is 4 less than or equal to 2 into 2? It is correct. So we might have reached from 2 comma 2, which is x minus 5 comma 2. But what if initial coordinate sx is equal to 3? Because from initial coordinate, we can only come to left, we can only come to right, or we can only come to top. We cannot go to any other quadrant of this. We cannot go to left of this, or we cannot go to right of down of this. So before checking whether this can be possible or not, this is sx, right? So if we are trying to reach to 2 comma 2, we are reaching back from 3, which is x is equal to 3. So this is not possible, because only from 3 comma 3 we can go down, we can go right or up, we cannot go down. But in this case we are coming down, so this is wrong. So what is the main condition to check whether we came from x minus y? It is simply x less than or equal to 2 into y. This assures that we are taking the maximum of x comma y coordinate, and x minus y greater than or equal to sx, because this is the old coordinate we are assuming, and the old coordinate should be greater than or equal to sx. Only then we might have taken this step. So if these both are correct, then we might have come x comma y. So if this is the case, then we can insert into q x comma y and the distance plus 1, because we are coming from higher coordinate. So initially the answer is 0 for tx and ty, and gradually we find the options and we will increase d, and we will insert into the q, and also we will find the unique hash function for that pair, and we will insert in the visited set to find whether it is visited in the future iterations. So if this is the case, then yes, we might have came from x minus y and y. So if this is the case, insert the hash function into visited set, and also insert into queue. So are there any other conditions to check? Obviously yes. So from this we got that for 10 comma 4 we are not able to come from 6 comma 4. So what is the coordinate from where we have reached 10 comma 4 by changing x coordinate? So that is the one left, right? So let's assume 10 comma 4, and so let's assume the point 10 comma 4. So from which value we might have come 10 comma 4? It is not 6 comma 4, because we discussed that if it is 6 comma 4, the new point can be reached is 12 comma 4, but not 10 comma 4. So for 10 comma 4, we might have reached from 5 comma 4, because the maximum of these both is 5. So 5 plus 5 is 5. See, 5 plus 5 is 10. So for 5 comma 4, if we use the original operation 5 plus max, it will be 10. So from 5 comma 4, we might have reached 10 comma 4. So why is this correct? Let's assume the original point is a comma b. Let's assume the original point is a comma b, and now we are checking for 2a comma b. So we are checking for 2a comma b. So what if a is greater than or equal to b? If a is greater than or equal to b, then maximum of a comma b is also equal to a. So then the new coordinate will be a plus a, which will be 2a, right? Because a is greater than or equal to b. So a plus max is also 2a. So if a is greater than or equal to b, then we might have reached 2a comma b. So if it is 2a comma b, we could have reached from a comma b if a is greater than or equal to b, because we have discussed that if it is a greater than or equal to b, then we might have reached 2a comma b from a comma b. And what a greater than or equal to b implies, we are at 2a comma b, right? We are at higher coordinates, and we are checking whether we are coming from any below coordinates, whether it is x comma y minus x or x minus y comma x. So we are at 2a comma b, and how to check whether this condition is getting satisfied? So it is simply we have to check a greater than or equal to b. So what is a? It is simply x by 2, because we are at 2a comma b and this is x comma y. So what is a? It is simply x by 2, and what is b? It is b. It is y. So if x by 2 is greater than or equal to b, it means that we might have reached from a comma b also. So with the before condition, we also have to want to check that if x is even. So we can use this operation only at even time, because if it is 3 comma 4, then how can we have it? How can we come from 1 comma something? It is obviously no, because we can reach 2a from a if it is only even, because if 2a is only even, then we might have reached it from a. So if it is 10 comma 4, we have to check if it is even, and if it is even, find whether a by 2 is greater than or equal to b, so that only then we might have reached it from a comma b. So check these both conditions, and similarly we can, okay, because is this the only condition to reach from a by 2 comma b? Obviously no, because same condition like this will come. We cannot go down to a6. So simply x should be even, the present 2a, and y is less than or equal to x by 2. We already discussed that a is greater than or equal to b, and x by 2 should be greater than or equal to a6. This is simply the same condition that we have used here, where x minus y is less than or equal to a6, where x minus y is the old coordinate. And similarly, what is the old coordinate here? X by 2 is the old coordinate here. So x by 2 is greater than or equal to a6. Here also, this is greater than or equal to a6. So if this is the condition, then we might have come from x by 2 comma y. So we got all the conditions when we are trying for x greater than or equal to y. So similarly, we can do when y is greater than or equal to x. So in this way, by reverse BFS, in a single BFS, we are trying to reduce half the coordinate, because here we are at AB, and if this condition is got satisfied, then we can simply push x by 2 comma y to q. So in this way, we are trying to reduce many operations. In this way, we can reduce daily and we can get the correct answer. So let's check the code. This is inputting and finding the answer. So initially, we want q, because x coordinate, y coordinate, and the distances so far. And we are using another set to find the unique hash values of pair x someday. Initially push tx ty comma 0, because we are coming from backward, and 0 is the initial step to reach itself, because we are assuming that we are initially at the last point and we are finding the minimum steps to reach the original point. And insert the hash function of tx comma ty. So it is simply we are multiplying the x by 2 power 32 and adding y, and simply while q is not empty, so pop the front value, and if it is already x6 and xy, return d, because we reached the present initial coordinate. And if it is less than xy or less than xy, it means that we are coming from bottom coordinates of s6 and xy, which is not possible, So just simply continue because this is not correct. And if x is greater than equal to y, then check these two cases. And if any of this is correct, then insert into set the unique hash value of that coordinate and insert into push into q with the new coordinate and d plus 1, because we are using BFS and we are moving one step forward. In this way, we can use two simple things, and one, the unique hash value, and other is coming from backward. So if you haven't, comment below. See you in the next video.